Absolute value in piecewise functions. This is scale and reflects actually scale and reflect absolute value graphs. Okay, so let's get this on, and the graph of y is equal to x is reflected across the z-axis, and it has a scale factor of 1/4. Well, this right here, anytime they mentioned about a scale factor here, or scale vertically by a factor, and I try to kind of lump this together and call this a scale factor. Anytime they have this scale factor, scale vertically by a factor of 1/4, they're talking about multiplication, because the word factor is actually part of the word multiply. So we're looking for is y is equal to, we're going to take the 1/4 because that's what we're multiplying by, and then we're going to have the absolute value of x after this. Notice the 1/4 is also positive, and we have the absolute value sign, so we know we're dealing with a letter V here. So the graph itself would be something that's opening up and going upward, and the 1/4 not only gives it the direction of going up and down, but it also tells you how wide the letter V is. So if we look at the possible choices here, we see which equation is equivalent to it. So what's the equation of the new graph? So what equation would be the new graph is? Oh, but now they also talk about it being reflected. So reflected means that we would draw a line here, and we would actually draw the V going in the opposite direction. So the V would be reflected, would means going in the opposite direction here. So when we come down here, we're not really so much looking for the positive, we want to do the opposite of it. So we're actually going to say y is equal to a negative 1/4, and then we have the absolute value of x, and the reason why it's a reflection, so we want to go reflect it across, so the x-axis we want to go the opposite direction, because the x-axis itself would sit right here. So this would be our first one, this would be our second one, so they would be reflected across. And actually, in reality, the letter V's would be more in line with each other. So if I go ahead and erase this right here, the letter V's would actually be more in line with each other here. So we could draw, a letter V here, and then we would draw a letter V here. So they would be more in line with each other, but since they're reflective, they would be going opposite directions. So since our first one was given to be a positive 1/4, well, what's the opposite of a positive 1/4? That would be a negative 1/4. So this would be y is equal to a negative 1/4, absolute value of x. Function g can be thought of as a scale factor of f of x is equal to x. So we want to figure out what the scale factor is. Now notice that this is your original. The blue is the original, and the G is the new one. So the G is the new, and the blue is the original. What we can determine about both of these, looking at them, is that they both go up. So they're both going up. So since they're both going up, we know that the scale is going to be a positive number. So that scale, which is going to be the front number, should be positive. So if we look at our possible choices here, we know that D is not going to work, and we know that B is not going to work as well. So what we're looking at is a 2 and a 1/2 here. So they say one possible answer, G of x is equal to 2 absolute value of x, and then the other possible answer could be is g of x is equal to 1/2. So g of x is equal to 1/2 the absolute value of x. Well, here's the thing, this is our original right here. So this is the original, and this is the new one. When you're dealing with whole numbers and fractions, you know that whole numbers are much bigger than fractions. But when you're dealing with absolute values, everything is opposite of that. In fact, these whole numbers, so when you have like a whole number here, you're going to find that the whole number is going to make the absolute value actually smaller. When you have a fraction, what it does is make the absolute value actually larger. So this was our original. Original was the blue, and for it to be smaller, it would have to be inside of the blue here. But actually, the red, which is the new one, the G, is actually on the outside of it. So actually, it sits on the outside. So it would actually lean more towards the fraction itself. So this right here would be more of the possible answers. Now, looking at the graph, you can also determine where's the 1/2 come from. Well, if you look at this right here, here's my 1. Here's the 1 right here. So if we have the 1 right here, and we go to the right of it, we go 2 over. So there's our 1 up and there's our 2 over, and that also helps show that it's going to be 1/2. But another thing to keep in mind is that when you're dealing with absolute values, whole numbers will make the letter V less, so it would be contained inside the original function. So the original absolute value was the blue. The new one is the red. And if you have a fraction, that tends to be wider. So here's the original is the blue, so it's going to be on the outside of the original. So the fractions will make it larger and bring it to the outside. So our best choice here would be g of x is equal to 1/2 x. Okay, now we have a graph of y is equal to the absolute value of x. It's reflected across the x-axis and then scaled vertically by a factor of 5/3. So again, we want to scale this vertically. So we're going to have y is equal to 5/3. Then we have the absolute value of x. So right here, we have our x-axis here. We know that 5/3 is positive, so we know the original is going up. Now we want to reflect this across the x-axis. So this would be our reflection here. And then it says then scaled vertically by a factor of 5/3. So again, we got the word reflected. So this is our original, which is 5/3, but we want to come up with the new one that was reflected across. So this new one, the formula, the equation would be y is equal to a negative 5/3. And then we have the absolute value of x. Because remember that when you reflect something, you're going to go the opposite direction. So our original one is positive. So 5/3, y is equal to 5/3 x. This is the original right here. This is the new one going down. So we know that anything that goes down, that front number should be negative. So A should be our answer. Okay, again, we have a function. This is our original function, and this is our new function. Just looking at the graph itself, we see that they're going up. So since it goes up, we know that that first number should be positive. Another thing we notice is that the numbers inside, the new function is inside of the original function. So the red is now inside the blue. So we're not thinking of a fraction, because a fraction would be on the outside, a whole number would be on the inside. So we're also looking at the graph here, we're thinking about a whole number. So we're thinking about a whole number, not a fraction. So this should be a whole number. So we're looking for a positive whole number here. So in a formula, y is equal to the absolute value of x, but yet there's a whole number here that's positive. So let's look at our possible choices here. So right here we have a 3. Right here would be a positive 1, and this right here is a fraction, absolute value over x. So that kind of looks a little bizarre, but that you could treat that as like 1/3 there. So that would be 1/3. Now another thing is, if we look at our graph itself, the vertex doesn't shift. It appears that everything here for our vertex, our starting point, so our starting point here, our vertex, would all begin from 0, 0. So there's no change to anything. So there's no change here. So basically, what does that mean? Well, the x is 0, the y is 0. So this right here would be our basic formula right here. Only thing we're going to do is put a number in front, and it should be a whole number. Because the red graph does not shift to the right, it doesn't shift to the left, it doesn't go up, nor does it go down. It appears that everything goes at 0, 0. So what we're looking for is just a whole number in the front, and let's write this down here. So it appears that this would be g of x is equal to 3 absolute value x. That looks like would be our best choice, because the fraction would make it go on the outside. Remember this plus 4 here, this plus 4 would cause it to be actually a negative 4, so it would shift the graph to the left. The graph is not going to the left. This right here, this plus 4 on the outside after the absolute value, would cause the graph to go up 4. It's not doing that. Everything is coming from the 0 for the x and the 0 for the y. This right here, D, would be our best choice, because again, like we talked about at the beginning, we knew that it's going to be a whole number because that new graph is inside. Anytime the graph's inside the original graph, it's going to be a whole number. We also know that it's going to be positive because both graphs are going up. We know that this is going to be the formula we're working with, and the formula y is equal to absolute value of x. We see that the starting point, everything is coming from 0, 0. So the x is 0, the y is 0. So the only thing we need is just a whole number in front. And the only one that gives me that is D.